Will they die? I've got to go to them.
If you leave now, help them you could, but you would destroy all for which they have fought and suffered.
Hi again, everybody. This week we're going to continue with our reviews and discussions about the YYC DataCon. And this time we're going to have Aysa do a segment on generating reality.
Today I'm going to talk about another YYC DataCon presentation titled Generating Reality by Micheal Lanham. Micheal is a software and tech innovator and has published several books in the field of AI. And if you like to learn more about this topic, you can refer to his recent book called Generating a New Reality. The picture in his title slide shows a snapshot of a video that's generated by a project in his book that replaces Julia Roberts' face by Scarlett Johansson's face in the movie Pretty Woman. In this talk, Micheal explains that generative modeling means being able to generate new concepts. For example, generating realistic images of cars or food or faces. He explains how this ML model is different from other ML models such as discriminative modeling or classification. So as you know, in classification, we try to find a function that separates two classes, whereas in generative modeling, we are trying to find the space or model the space that encompasses the images of dogs or cats. Then Micheal talks about the real world examples or applications of generative modeling. One of them is animating faces that converts static images to animations. Deep Nostalgia website animates the old photos by incorporating a driving video. Another application which is very important is in advanced diagnosis in medical field. It has applications for in oil and gas. Drilling companies can predict where to drill. There is another application called Synthesia that Micheal talks about, and it generates news feeds for emergency news. It fits the script and the picture of the reporter, and then without the reporter actually reading the news, there are applications in your mobile that you can superimpose famous person's face on your face. Next, he gives an introduction to the structure and building blocks of generative modeling networks. He starts first with the first generation of generative modelings that are called autoencoders, and it goes back to decades ago. And he explains how autoencoders can get an image, then find its latent space, and based on that, it has a generator that generates new images. Then he talks about some variations of autoencoders, and most importantly, the GANs or generative adversarial networks that are very popular now. It's similar to autoencoders, but they are way more complicated than those. They basically have two separate parts that are working together, discriminator and generator. After introducing GAN, Micheal talks about different types of GAN that are divided to three categories generally: generic GAN, image to image, and ampere cycle laws. Generic GANs work based on understanding the representation of data and generating new samples. Image to image is, as an example, you can say drawing something and then generating a real picture of that. We can see this drawing of a bag, and then GAN network gives you the picture of this bag. Then Micheal talks about one of the most controversial application of GANs or that are deepfakes, and he explains that they have two different types: face swapping, which is simpler, and post swapping, which is a little bit more complicated. And then he discusses the potential harms that it can bring: political misrepresentation, brand misrepresentation, security issues, face identification, and loss of creative art jobs, graphic designers or artists, musicians. After that, he discusses the methods that are currently being used for identifying deepfakes.
Bond. James Bond.
Well, I'm flattered. I prefer the revenge department.
The first thing is, Jules, forget about disco. Grind your teeth. Relax your jaw. Out without moving your lips. All right?
1, 2, 3.
In generative modeling, there is the generator that is sort of generating the new piece of stuff, and it's generating based on the learned representation of that space, right? So the generator essentially learns the representation of that space, but in order to help that understanding or learning, we often introduce a discriminator or a classifier. And that classifier then can sort of break down or understand a little better what each of those sort of bins or those spaces looks like, and it sort of helps the generator along. And again, the discriminator essentially is discriminating between real or fake images, and that gives the discriminator the ability to be able to learn what's real or fake, but also a better understanding of what is fake. So when the generator is generating a bunch of random noise or random information, the discriminator then can say, okay, well, that's actually not real, and this is real, right? So if you take a classic example of just doing discriminator training or classification training, you're often just, doing supervised learning where you're feeding images in that are all real. You're not feeding any fake images in, and you're really just trying to classify on what those real images are. By introducing this sort of adversarial learning, if you will, we increase the robustness of the discriminator, because the discriminator is now exposed to ad hoc images that could be on the borderline of real or fake, that may not even be in the domain that you want to train the discriminator on.
So this kind of application will help to, I'm wondering if this helps to control all the deep fake news that are generated.
Well, and there is, right? There is a whole area of discriminators being built to try and analyze deepfakes to say they are fake. And we have a whole bunch of techniques to do that. The problem with that is it really comes back to the adversarial learning sort of architecture of the GAN, is that you have the generator that is learning on the discriminator, and if you sort of push those tools in the discriminator to analyze deepfakes, then the generator can just make the fakes better, right? Because it learns how to make the fakes not look fake.
I knew about the classifier or discriminator in this network, but the way that we use this as the main objective of the network, I never thought that way. But now that you're explaining, and I'm thinking it, because we are most of the time training a classifier with real inputs, whereas now we have both real inputs and we can say that these are real, but we also have fake inputs that we can tell and train the classifier that these are fake. That's what we don't have in conventional or classic classifiers. And they are helping each other and making the more powerful discriminator. That's very interesting.
The typical classification discriminators that are just trained on classification data, they become very hackable, right? Because you can essentially feed in, and there's lots of examples and papers of this where they're feeding in almost garbage data but it's constructed such a way that the classifier looks at it as, oh, well, that's a dog, but it's actually nothing like that. And that's where you get this sort of hackability of the deep learning networks or models, where by using generative modeling or a generator to train the classifier or the discriminator, you're getting a more robust model that can understand what could be sort of within those bounds, right? So it's sort of, it only understands what the real space or representation of what the data should be, and then it can ignore that other outside space where classically trained discriminator or classifier doesn't do. So that, we're looking a lot more at adversarial learning, not just for generative modeling, but also to improve the classifiers themselves.
Where do you usually create this type of models? Do you use like a software, and which programming language?
Yeah, so they're all done in Python. The book is with PyTorch, and all the examples are on Google Colab. So you can just go on Google Colab, which is a free platform. You can run the models. If you go back, I think a couple slides where the fake foods and the fake cars are showing, those were generated by the StyleGAN version 2, which is like the top of the raw generated GAN models. And that took about 2 or 3 days to generate those. But overall, they're generally pretty efficient. And the nice thing about Colab, it actually gives you GPU training that you can use. The food example is trained on 200,000 food images, and the car example was trained on, I think, 100,000 car images. And the car images were all different views of the cars, different orientations, actually some inside views, etc. And the food data set was essentially just people's pictures posted to Instagram of food. And it fed in, and that's what it produced. Now, this is sort of a subset of the representation. If you were to look at sort of the whole model representation, you'd get a much more variation, and you might get some funny-looking images in some cases. But these examples turned out really well because you can see it. It looks like plates. The background looks realistic, everything, right? So, I mean, we're getting really far with the generative modeling.
It's very impressive, yeah.